ADVA, we're very excited to launch a new product to our portfolio that's bound to change the way that our customers can deliver Ethernet services. It's a new flagship box called the FSP150 XG210. Traditionally, ADVA has focused our Ethernet access product line on Ethernet OEM and SLA monitoring. Our strengths have been service assurance and testing. We've also now grown into the aggregation market, the synchronization and timing distribution field, and continue to develop our TDM interworking and replacement strategies with both Ethernet over TDM technologies as well as circuit emulation technologies. Ethernet service delivery is a long strength for ADVA, and we've looked at the things that are important to a carrier when they're delivering an Ethernet service. Everything in the life cycle, from turn up and test to monitoring that device once it's rolled out, and then reducing truck rolls when there is a problem in the network. And of course the OSS system that's going to collect the data and help us track alarms, monitor, and troubleshoot. The XG210 is an expansion of this product line, and the release of it is going to bring out the same stuff that we've been doing for GigE and Ethernet over TDM, now also for 10 Gigabit Ethernet, for both 10 GigE service delivery as well as Gigabit Ethernet service delivery. Our focus on service assurance really came to fruition with the proliferation of mobile backhaul in the industry. Mobile backhaul is a killer application for service assurance because it involves an in and I between a transport provider, an access provider, as well as the mobile operator. And the mobile operator is buying a service now that's replacing what they had been used to in a TDM world with now Ethernet and asynchronous packet-based technology. That mobile operator has a certain SLA that they require to make sure that their cell towers work and that handoffs from cell tower to cell tower happen seamlessly as somebody is traveling in a car. And they need to make sure that there's a delay, jitter, and loss measurement to each of those cell towers that's always being met by their access provider. The access provider SLA now has gotten much more strict than it was just for business Ethernet, in that we're carrying about single-digit millisecond or less delay and jitter measurements, and of course, virtually no loss. So service assurance has been key for our products in the GigE realm and will continue to be key now for 10 Gigabit Ethernet, whether it's on the access side or the hub collection side. Wrapping all these features together, we need a carrier class management system that can both talk to all of the different types of our network elements for ubiquitous Ethernet, as well as talk to multiple OSS systems. When we're delivering thousands of Ethernet access devices, management integration is extremely important. We need to be able to collect all the data, make sense of the alarms, and integrate it not only with some other OSS system, but make sure that we're compatible across all of our different types of access devices. And incidentally, our carrier class management system is the same one that also controls our DWDM product line. Ethernet access topologies change from region to region, and they also can grow within even one marketplace. So our product lines support several different types, whether the customer is hub and spoke, doing a linear connection out to each end device, whether they're growing into rings, or whether they're already into a ring environment. The XG210 will be able to work in a homogeneous ring, where it's just a single device on one common ring. We'll also be able to interoperate, particularly with our EGX aggregation platform, and be able to do ring interconnection. ADVA's Ethernet access CPU portfolio is now strengthened with the addition of the XG210. We already had native 1 GigE demarcation with the GE201, and we had multi-port GigE demarcation as well as aggregation with the GE206. The XG210 is able to handle not only demarcation, but aggregation and multi-port CPE for a multi-tenant application all in one box. With the modular client ports, we can have a single 10 GigE client going to redundant 10 GigE uplinks. We can have multiple 10 GigE clients, or we can have a whole bunch of GigE clients. The XG210 is truly our flagship product. Very versatile, very powerful, very fast.
Hi, Kevin Weeks here, Director of Product Line Management for Ethernet Access at ADVA Optical. Here to talk to you about the XG210 product today, ADVA's newly announced 10 Gigabit Ethernet product. I'll be discussing some of the technical details and giving you an overview of the capabilities of the FSP150СС XG210. The XG210 features two 10 Gigabit Ethernet access ports, allowing network protection, supporting both WAN-PHY and LAN-PHY modes, and allowing you to do rate conversion between WAN and LAN PHY rates between the client and network ports. Client ports are supported via card slots, which can adapt to hold 10 gigabit ports or multi-port GigE client ports. 10 gigabit ports offer XFP, SFP+, and RJ45 media types. The 8-port Gigabit Ethernet card is an SFP-based card that allows the system to support up to 16 SFP Gigabit Ethernet ports, allowing the XG210 to do network aggregation applications as well as its traditional network interface device or NID applications. The mechanics feature a 1U chassis that is an industrial temperature compliant chassis. The device features a replaceable fan module consisting of multiple fans and a fan filter that can be changed or cleaned on a maintenance basis. The device features dual PSUs that are hot swappable, allowing for redundant power connections. The system also supports timing and synchronization capabilities through synchronous Ethernet interfaces, as well as through IEEE's 1588 V2 precise time protocol. The chassis features time of day, 10 megahertz clock, bits, and pulse per second ports, which can be configured in input or output modes. The system also features dry contact alarm inputs for monitoring environmental conditions. The XG210 supports the same QoS features found on other ADVA Optical Ethernet access products. 8 classes of service per port, twin rate policing allowing for committed and excess information rates, 3-color marking, dedicated queues and scheduling instances on a per port or per EVC basis, weighted round robin scheduling and strict priority scheduling, as well as traffic shaping per port and per EVC, round out the majority of the capabilities of the XG210's traffic management engine. We are also an MEF compliant system supporting coupling flags for bandwidth sharing and color aware or color blind markings. The dual network ports on the XG210 allow us to offer network protection. Network protection can come in the form of link aggregation, where the device is compliant with IEEE 802.3 Annex 43C link aggregation in an active standby mode, where frames are bridged on transmit and then a selector receives from one of the 2 network ports on the receive direction. Link aggregation is supported on the network ports, allowing the system to provide network protection. The system provides an active standby or one-for-one protection mode that is compliant with Appendix 43C of the IEEE 802.3 standard. In this mode, the protection works on an active standby function with no load sharing between the protection link and the working link. The working link is assigned a priority 1, protection link is assigned a priority 2. If the working link fails, the traffic switches to the protection, and revertive switching is supported if link aggregation control protocol is enabled. Link aggregation control protocol can also be disabled on the system and provide faster switching times, sub 50 milliseconds. Both EFM and 802.1ag protection switch triggers are supported, and the system provides a full lag MIB support for SNMP control and monitoring of the link aggregation function. The XG210 also supports the same OAM and demarcation features found on other ADVA access products. These include our extended Ethernet performance monitoring capabilities, port and VLAN loopbacks in both facility and terminal directions, as well as timed loopbacks. The EtherJack Connection Performance Analyzer, or ECPA, is an embedded traffic generator traffic analyzer function that allows the system to support inline and out-of-service testing of circuits that are configured through a customer network. Additionally, EtherJack Service Assurance, or ESA functions, allow in-service monitoring of SLA parameters across a system or across a circuit, featuring both Layer 3 IP-based mechanisms as well as industry standard Layer 2 Y1731 SLA monitoring functions. Link loss forwarding is also supported, both across the device, where a network port can be programmed to take down or disable a client port, as well as cross-network forwarding, where the network can act as a virtual wire, sensing a customer port failure on one side and link loss forwarding that to the remote side so that the customer sees the link go down as if the network were a wire in itself. Local and remote management, as well as software upgrade and database backup functions, are also supported. The timing and synchronization capabilities of the XG210 are very flexible. System timing modes include line timing using the synchronous Ethernet ports, external timing through bits or GPS clock inputs. As well, the system features an ITU-T G8262 standard compliant clock. Synchronous status messaging can also be enabled on both the synchronous Ethernet ports as well as the bits ports. The bits capabilities feature both T1, E1, as well as 2048 kHz square wave signal encoding mechanisms. A GPS clock can be used to determine time of day, and this clock can be configured as either an input or an output, where the system can receive time of day from an external entity, or it can generate time of day from its own calendar clock. Pulse per second input also provides very, very close clock alignment on a per second basis. This allows the system to accept synchronous Ethernet inputs, for instance, on its network port and generate sync E on the client ports. Or sync E can be taken in from a client port and used to generate timing for the network ports or other client ports. Bits timing can also be derived from synchronous Ethernet inputs, and that can be used to drive a standard network timing function using E1 or T1 facility types. Additionally, bits in can be used to drive the system clock, which then can be used to drive synchronous Ethernet outputs on sync E enabled ports. 1588, which does not depend on any physical interfaces, but is a timing stream carried over packets, will also be supported by the XG210. In conclusion, the XG210 fills out ADVA's ubiquitous business Ethernet service delivery platforms, which range from devices that can transport Ethernet services over T1 and E1 all the way up through 10 gigabit Ethernet.